important for you to have your own technique, it's equally important for you to know the math behind. Let's identify the math behind the keep, change, flip method when dividing fractions. Usually, when we divide fractions, we are told to reciprocate one of the two. Its common name is called the keep, change, flip method. This method has three specific steps given by the name itself. Keep stands for keeping whatever the dividend is. Change stands for changing the operation instead of division into a multiplication. And flip stands for reciprocating or flipping the divisor. In illustrating this method, let us use these two fractions. Let us have 1/4 to be divided by 2/3. First, it is essential for us to determine which of the two is dividend and divisor. Please be guided that the first fraction to be given in this expression is what we call as dividend, that's 1/4, and the second fraction, which is 2/3, is your divisor. Now that we are clear with this, let us proceed with the steps for the keep, change, flip method. First, let us keep whatever the dividend is. In short, let us still use 1/4. Next, we are going to change the operation into multiplication. Hence, we will have this expression. Take note that when we write expressions side by side using parentheses, that's automatically multiplication. And finally, we are going to flip or reciprocate the divisor. So instead of 2/3, we are going to interchange the values in the numerator and denominator. And the value is, instead of 2/3, we will get 3/2. If we are going to continue with this process, instead of dividing the fractions, we are just going to multiply the fractions. And again, when multiplying fractions, we are to multiply the numerators and the denominators separately. So 1 times 3 is 3, 4 times 2 is 8. So this would mean that the quotient when 1/4 is divided by 2/3, the result is 3/8. We all know this process, but do we have an idea on what is really the math behind this method? The secret behind the keep, change, flip method is a combination of an inverse and an identity property for multiplication. With the same given, we could always write this in a form of a rational expression where the dividend, which is 1/4, is the numerator, while the 2/3, being a divisor, is the denominator of the said rational expression. We can illustrate the math behind this method when we are going to multiply this expression by another rational expression. The denominator of this new rational expression should be the inverse identity of 2/3. When you say inverse, it's the reciprocal of it, which is actually 3/2. Now, the denominators represent the inverse property of the other. 2/3 is the inverse property of 3/2, and 3/2 is the inverse property of 2/3 under multiplication. To make sure that the rational expression we are multiplying to the given does not affect its value, we need to set up a numerator which is the same value of the denominator. Hence, the numerator of the second rational expression should be 3/2. In this way, 3/2 divided by 3/2 is just 1. This is where the identity property comes in. 3 halves divided by 3 halves is just 1. So we are just multiplying 1 to the given expression and not changing its value. Do not simplify this yet, since our goal is just to show that the math behind the KeepChangeFlip method is the inverse and the identity property for multiplication. Next thing is we're going to multiply the given expressions. When we multiply the denominators, since we are multiplying 2/3 and 3 halves, being one of them is the inverse property of the other, the result will be 1. Because that's 2 times 3, 6, and then 3 times 2, 6. 6 over 6 is 1. That is why our result is 1. As for the numerators, we will now have 1/4 times 3 halves. If we are going to just continue with this, we all know that any denominator 1 could be simplified. That's why our final result is just a product of 1/4 and 3 halves. Now, if we are to cover this middle part, we could see that the first fraction in the final form is just the same as the first fraction in the given. In short, we just simply kept it that way. Next, we could see the difference in the operations, that in the final form it is in multiplication, and it looks like we are just changing the division into multiplication. And finally, the second fraction in the final form looks like a reciprocal or a flipping of the divisor in the given. Supposedly it's 2/3, right now it's 3 halves. As a summary, it looks like we kept 1/4, we changed the operation, and we flipped 2/3. This is why when dividing fractions, we are told to keep the dividend, change the operation into multiplication, and reciprocate or flip the divisor. This is the math behind the KeepChangeFlip method when dividing fractions. Hello everyone, please watch out for more math behind videos.